Okay, so I've done some more looking into what this meter is doing. I'm not too sure if it is the batteries or not, or what's happening, why it's actually keeping the capacitor from discharging. But yeah, um, I've done some tests, as you can see. This was the original. This is a rebuilt version because I thought maybe my diodes were off, maybe the capacitor. No, different diodes. These are a bit beefier, bit better quality. Capacitor is the same. I tried to keep that the same. I've tested it though, and it works like a normal capacitor should at that level. Though I don't have proper equipment to test it like fully to see if it's to spec or anything. I can just see that it does what a capacitor or electrolytic capacitor should do. Um, and yeah, there was a suggestion in a comment to see what the effect on the battery is, if any. And I think that's an interesting thing to do. I might do that. This one here is the one that takes two AAAs. I made a mistake in my last video saying that this one had the AAAs. Now this one actually uses a 9 volt, although still, again, that's not going to be enough to charge the capacitor to 12 volts. Same with like 3 volts on that one. So, and this is just to show that it does it on many different meters, not just the one. So I'll disconnect ground. I've got ground disconnected, and as you can see the voltage will drop, but it will go down to about 11 volts or just below 12, depending. Sometimes it's a bit different. You can observe the dimming of the LED as well as an indicator. But yeah, so yeah, there it is. It should be about steady around there. Now again, if I touch the other AC side of the rectifier, it will start to charge because I'm grounding, so that's normal. Just a quick reference, that's what we're doing here. We don't have the resistor in at the moment. As you can see, the black is going straight to the collector. It's not going through a diode. So yeah, we've got that. Now, as soon as I disconnect the multimeter, as you will see from the connections, that LED will go down fully. It takes it a few seconds, but it will go down, meaning that the cap is fully being discharged into the LED, and it's no longer just the collector providing power or a path for charge. It has to be the meter. But why when it's connected on positive and negative? That's the odd part. Now, looking at how a bridge rectifier works, I'm wondering if it's something about the negative of the battery in such a high potential on the collector that it's somehow forcing that the MM to keep that electrolytic topped up as in some sort of way. But again, is that actually chewing the battery in the MM faster? Is it recharging it through some sort of negative resistance perhaps? As I do notice that some of my meters, after saying low battery in other experiments, I'll bring them around fields like this and then they'll just go back to working normal. I don't know. That's happened only once, and it's a very old observation that I did a while back that I've forgotten about, and this phenomenon here has kind of reminded me of that. Could be completely unrelated, so I don't know. But it's just something interesting. So yeah, now we've got the LED fully unlit, and if we connect the meter to the bridge and capacitor, you will notice that the capacitor slowly starts charging. So as the comment said, sorry I forget what your name was in the comments. Hopefully I'll reference you next time. Yeah, I need to create a procedure to test the battery. It's going to be a long test though, because even with AAA's, I guess what I could do is discharge them until this thing says that that's giving me a battery warning. Leave it here for a bit, connected to the whole field in this way and many in other ways, and see if eventually that battery goes to not saying that it's a flat battery. I don't think that will work too well. I would have to discharge the battery, leave it for a while, make sure it settles, then put it into the machine. It's a lot of days of work. But yeah, I know what the testing needs to be done to be thorough. It's just you're always trying to cut corners when you're doing it for free. So, but yeah, it might be that that's going to be the only way we can see fully what's happening, if it or rule out the battery use, I should say. Because yeah, I'm still to test those ones to see if that does it. Okay, well, another point of remembrance is that no, I don't think that's going to be important. Yeah, I'm not sure what else we can test out here. I still have suspicions that Gomez is having the same an issue with the multimeter doing the same thing. His latest video, part 4, he has his multimeter connected to it. Although he says in the thing that he knows about these effects, and in the film he does reference these sorts of things, so he knows that there is a problem and that sort of thing arises, which makes me suspect that it's not playing an effect in this case. Or, I don't know, maybe he is just being willfully ignorant or something like that, but hopefully not. So yeah, but in any case, I'm interested in this now, because this has really got me stumped. I don't understand. Yeah, it has to be a grounding issue, because yeah, when you ground yourself, but why is it charging? Where's the... I guess this is just a dielectric, and because of the way that the impedance flip-flops between the dielectric as you ground it on one side or another, it doesn't really care which side of the energy it's coming from, as long as it gets an impedance difference or a differential, and it will just flow. And because we're rectifying it with the diodes and dumping it into a cap, it really doesn't care. It's a grounding issue that it cares about. It just needs the path, which one really it is, and it doesn't care. Yeah, I guess that sort of could make sense. Okay. Anyways, yeah, well, that's 10 minutes of mental therapy. All right. Thanks for watching.